Integers and rational numbers, page 64. A lot of this information is going to be review. However, they're going to, where in the past, a lot of these things were separate lessons on their own. Now they're just going to take a lot of this stuff and just cram it all into one, just assuming and knowing that you have seen it before. Whole numbers are the numbers 0, 1, 2, 3, etc. Integers are the numbers -3, -2, -1, 0, 1, 2, 3. Positive integers are the ones greater than 0. Negative ones are the integers that are less than 0. So they basically just give you a rundown of your everyday number line. Any questions on a number line? Integers. Once you speak of integers, the understanding is now that you're moving into the negative numbers. Compare and order integers. When you have to order integers, sometimes they may ask you to, graph the points on a number line and order them from least to greatest. Well, if you graph them on the number line, that's what you're doing. You're ordering them from least to greatest. Because what do you know about the number line? The further to the left you go, what happens to the value of your integer? The further to the left you go, what happens to the value of your integer? Yes? It gets lower, smaller. The further to the right you go, it gets greater. Okay? Now, rational numbers are something that you may be just a little bit less familiar with, and there's certain rules that go along with what makes something a rational number. Integers belong to the set of rational numbers. A rational number is a number a over b, where a and b are integers and b is not 0. So when we speak of rational, they tell us that a rational number comes in the form of a over b, as long as b does not equal 0. Okay? Now that's going to cover a lot of different kind of numbers. For example, the number 4. Would 4 be considered a rational number? Can you put 4 into a over b form, Mark? How? Good. 4 over 1, 8 over 2. Yeah, there's different ways in which it can be done. The value itself would still stay at 4, okay? So when you see that, that's fine. How about a -16? Can you put that into fraction form? Yes? Sure, just put a negative in front of it. Okay? Same kind of deal. Okay? What about that rational decimal? Yeah. Can you put it into a fraction? Yeah. What is it? The 8 is in the tens place, 8/10, right? Okay, so that'll work. There are more cases in which a number is considered to be rational than not. For example, it is not rational, okay, if the decimal does not terminate or repeat. So in other words, if you have a repeating decimal, that would still be considered a rational number. And give me an example. Do you know of like a fraction that would produce a repeating decimal? What is 2/3 as a decimal? Yeah. 0.6 repeating. It's a neat trick with that too, because if I were to put this back into fraction form, my 6 is in the 10th place, right? Well, 6/10 does not give you a repeating decimal. However, in cases of repeating decimals, and you'll see this as we move on further, you take 1 away from the denominator. 6/9 is equal to what fraction? 2/3. Okay? So we'll see those cases that'll come up. This would be okay. That would be rational. That would be rational. That would be just fine. Okay? Where you get into problems are a lot of the times when you work with square roots. What is the square root of 16? What times what? Same integer times itself will give you 16. 4. So would this be considered a rational number? Yeah, we already covered that we could use 4 as a whole number, as specific. But how would it just go down 1 to the square root of 15? Here they are. Calculators. Handy little carrying case. Nice, huh? Well, not necessarily. 7.5 times 7.5, right? So I'll pull out the calculator. So Marlia, punch in the 15 and then hit the square root button. See what you get. Can you tell me? 8.3, what? Does this follow any specific pattern? Could I use bar notation to show that this is repeating? Why does it stop at this 3 on the calculator? Because it only has so much room. This thing will go on and on and on and on. That would not be considered rational. So if you don't have the perfect square inside of your square root symbol, that's a case where you'd see it not being a rational number. Okay. What about if you had an improper fraction, 19 over 3? Whoops, that already is. I did it backwards. What if you had 5 1/4? Could you put that into a over b form? Yeah. Just convert it to the improper fraction. That would be fine. 21 over 4. That would be fine. Okay. So there's a lot more instances of rational numbers than there are of irrational numbers. Okay. But integers are your whole numbers, your counting numbers. So if they ask which of these would be integers, go back. Would this be considered an integer? 4? Yes. How about 0.8? Integer? No. No, as far as the integer is concerned. Our whole numbers, our counting numbers. Negative 16, integer? Yeah. More likely to see that on a number line, right? You're not going to put 0.8 on a number line, not if you're just making your own. Okay. 2/3, integer? No. Here, yes, as far as the 4, integer, no. Okay, so 19 over 3, no. 5 1/4, no, that wouldn't be an integer either. Okay, any questions so far? Bottom of 65, let's take a look at that. Guided practice. Tell whether each number in the list is a whole number, an integer, or a rational number, then order the numbers from least to greatest. So here's the first one that we have, the first example, and they give us a 3, a negative 1 2/10, a negative 2, and a 0. You want to order these first? Least to greatest? Let's order them first. Least to greatest, What do we got first? Cascade. Followed by 0 and 3. Okay. Now they want to know, are these considered whole numbers, integers, or rational numbers? How about number 2? This negative 2. It would be rational, integer, rational, right? Whole number? I suppose. But if they're going to try to make the difference between an integer and a whole number, I'm assuming they're going to reserve the integers for the negatives and the whole numbers for the positives, right? We'll just make that assumption. How about the negative 1.2? Integer? No, but it is a rational number. How about 0? Suppose, we'll put this down for whole number too. Whole number, integer, right? And how about the 3? Whole number, integer, rational number, the whole 9. Try number 5. Try number 5. Order it and see if you can just kind of identify the numbers a little bit. Least. Marlia. Negative 2.1. And then obviously the negative. How did you make that distinction between the negative 2.1 and the negative 3/4? How did you know that the negative 2.1 was actually smaller? What if you just reason with it? It's a 2, and this isn't even negative 1, right? So followed then by the 0.5 and the 4.5. How about the negative 2.1? What we classify? No, it wouldn't be an integer, wouldn't be a whole number, but it definitely would be rational. The negative 3/4, again, not a whole number, not an integer, but definitely rational. 0.5, rational. 4.5, rational. Okay, none of those are whole numbers. None of those are integers in which you would find on your number line. Okay, so pretty straightforward stuff there. Okay. Opposites. Opposite of a positive 4. Opposite of a positive 8. Opposite of a negative 100. Any questions on opposites? Absolute value. Absolute value. We've covered absolute value a little bit with the math group. Absolute value of negative 7. In other words, how many places from 0 from negative 7 is, how many places from 0 is negative 7? Mark? 7. When finding the absolute value, you may have negatives on the inside of your absolute value bars. However, you never have such thing as a negative absolute value. It still has value. So if you had the absolute value of a 4, it would be how many places from 0? 4. Okay? So don't confuse opposites with absolute value. Okay? Page 67, I don't know if we need to waste our time with numbers 5 through 13. Do I need to have you tell me which one is greater between a 0 and a 7? Do I need to have you tell me what is greater between a 0 and a negative 4? Do you have that handled? Page 68. At the top, 14 through 22, just order them. I mean, I don't need you. I think we've covered a little bit, for you to understand, and you'll get to some of this other stuff as we go, but Just order those. That's all I'm asking. Just order those. And then 23 through 34. For given value of A, find negative A and find absolute value of A. So let's take a look at 23 together. They want us to find negative A and the absolute value of A. So the first thing they give us for number 23, A is equal to 6. Now, the first part here, when they say they want negative A, basically, you're going to multiply your A, whatever A is, by what is there. Negative what? What's the skinniest number that can fit in between there? It's a negative 1. So essentially, what's going to happen to this? What's going to happen to your number? It's going to switch sides. If it's positive, it's going to end up being a negative. So because what is, if A is 6, what's 6 times a negative 1? Negative 6. Then the absolute value. How many places from 0 on a number line is 6? 6. 24. What do they say A is, Marlia? They say A is equal to negative 3. So if I'm going to plug it in there, a negative 3 times the negative 1, it's going to flip the sign again, Mark. It's going to be the positive, and the absolute value of the negative 3, distance from 0 on a number line, 3. That's what they're doing there. Okay? Any questions? Not that bad? Let's do 14 through 34. Page 68.